Page 2 of G4 notes, and we're looking at independent versus dependent events. So, if A and B are independent, then probability of B does not affect probability of A and vice versa. So what does that mean? That means the probability of A given B is not affected by B. It's just the probability of A. That was kind of like the probability of green, or really the probability of red, when really the same. And if I have probability of B given A, that means it's the same as probability of B. So A doesn't affect the probability of B. Now, events that occur without replacement. So if I don't put things back, I'm usually changing probabilities, which means it's dependent. Let's take a look at some of these sets. Which set, and only one of these, is dependent? Drawing a marble from an urn, replacing it, and drawing a second marble. I haven't changed the probability for the second one, so that one's okay. Rolling a die and drawing a card. The die doesn't affect the card, so we're okay there. Drawing two marbles from an urn. Since it is implied that I'm keeping them, this looks like it's my answer. Rolling a die twice. Well, because the second roll doesn't depend on the first one. Those are independent. Here, which set of events is dependent? Rolling a die and flipping a coin. There's no relationship, no changes in probabilities. Drawing a card and flipping a coin. Flipping a coin twice might be tempting. No, those are still independent. But drawing two cards from a deck, if I'm trying to draw aces and I've already drawn an ace, I've affected my probabilities. And actually, even if I drew a king, I've affected my probabilities because the total number of cards left in the deck has changed. So this brings us to the multiplication rule of probability. When they're independent, we'll just plain old probability of A times probability of B. And if it's dependent, I have to use the given probabilities. So I will do probability of A times B given A. This assumes that A happens first. Or, what if B happens first? Well, then I'd need probability of B times probability of A given that B happened. So B happens first. Okay? And sometimes when either one could happen first and you're just interested in the total, you might have to add these two answers to get the probability of A and B. So pay attention to if the order is an issue or not. Okay? Now, if we know probabilities, we can use this rule to make predictions without having to count every outcome, so we can just do products. Now I'm looking at batting averages of some Round Rock Express players. These are actual batting averages from a couple of years ago. And the question is, are the batting averages dependent or independent? Does one batting average affect the other? Well, hopefully not. They're independent. So the question is, the first two batters for the third inning are Carlos Baquero and Thomas Tellis. Calculate the probability that Carlos gets a hit and Thomas does not. So I'm trying to find the probability of Carlos and Thomas. Oh, complement for Thomas because not getting a hit. Well, these are independent, so I can just go ahead and multiply the probabilities. The thing is, for Carlos, probability is 0.667. Because I'm doing Thomas doesn't get a hit, I actually have to subtract the probability he does get a hit. I'm doing the complement. So it's the product of 0.667 and 0.67, which I'll go ahead and calculate really quickly, which is about 0.447 roughly. I rounded. Okay. Probability the first two batters for the ninth inning are Hanser and Kyle. Calculate the probabilities that both get a hit. So that's Hanser and Kyle both making hits. So this one's even easier. I don't have to do a complement. Just multiply the two probabilities. Hanser's probability is 0.302 and Kyle's is 0.327. Which is roughly, after rounding, 0.099. Okay? What are the probabilities of rolling an odd number on a die and flipping heads on a coin? Are these dependent or independent? First of all, they're independent. All right? So we're trying to get an odd and heads. All right? And that's the order we're going to do them in, so I don't have to worry about backwards and forwards. So it's going to be the same as probability of odd on a die times probability of heads on a coin. Odd, half the numbers on the coin are odd, and half of the flips are heads, hopefully. So this same as a half times a half, which is 1/4.